Have you ever noticed rap is essential in spelling graph? If you haven't, then I'll kindly just give you a little slap with this track that I'm laying down. I'm not playing around. This is serious business, and you would be very foolish to miss this groovy little lesson that I'm blessing your ears with. A skill that you may implement and follow in years if you follow a career path with mathematics, or even if you're just a normal student turned math addict. Now, while I'm packed full of the knowledge that you will soon learn about determining the area down under a curve. Yeah, a curve. Let's start this lesson with whipping out our calculators. No need for stressing, but we can't put off this calculator. So I'll begin by telling all of you an easy technique. But when I'm done, don't forget the fact you heard it from me. Step 1, you enter the function into the calculator. Easy is choosing between a starburst and an hour later. But before an hour later, you'll learn these winning techniques. So step 2, you press a second in the calc key. And press down till you now see number 7 highlighted. Now go and enter that, please. And step 3, the screen will request for some digits. But not your phone number, just the upper and the lower limits. I'm talking bounds, what you integrate between. Punch them in, press enter, you're done, so now scream.
I'm feeling mighty fine, now that I finally learned how to find every year down under the curve. I'm feeling mighty fine, now that I finally learned how to find every year down under the curve.
But not so fast. Please refrain from cheering. There'll be plenty of time for that after you're done hearing the full lesson that I've painstakingly planned out. No need for thanks, just reach your hand out and plan on leaving it there, cause you'll be needing it there for some manual math handling. But please don't be scared. Now here we go, you gotta write the sign for integral. First of all, it's kinda like the letter S, except abnormally tall, and it's accompanied by numbers on its top and bottom values you integrate between. Would it be good if you forgot them? But do not stop then, cause here's what's next. You gotta write down your function, follow it by dx. And like a text, don't try to write it while driving, cause next you gotta do some anti-deriving of the function that you recently wrote down. Feeling tired? Too bad, no time to slow down. Take the antiderivative of the function that you just found and plug it into it, the numbers that are chilling in the bounds. Take the top and proceed to subtract the bottom. The resulting answer is area, so you should feel awesome. Now that you have reached the day, you can crack a wide grin and go and proudly say,
Wait, hold it right there. You completely forgot to explain how to find the area under two intersecting curves. You take the integral of the top curve and subtract with the intersect of the bottom curve. Okay, you may now proceed, Connor, and don't skip a beat.
I'm feeling mighty fine now that I finally learned how to find every year down under the curve. I'm feeling mighty fine now that I finally learned how to find every year down under the curve.
I have no doubt that you're probably now feeling pro status, but Mrs. Humbert would surely kill me if I did not make sure to add this final technique. But I must warn you that it is not for the weak, and I'll admit at times it even scares me right out of my seat. I like to call it RAM, but not like the animal, and right now if you're confused, it's completely understandable. RAM is really simply just an acronym, and rectangular approximation method's what it is. And RAM is of varieties left, right, and mid, so let's go ham on some problems to see how it is. Yo. Yeah, let's go ham. Listen as I implement examples in my explanation to permanently ink your brain cells with information. So I'ma take x squared all the way from 0 to 4, but know that right RAM is an overestimation, of course. Now on the graph you wanna draw 4 rectangles, and while using right RAM you don't wanna get your facts tangled. The graph should intersect each other right hand corner, so by my count that's 4 places that it crosses the border. So now I'll order you to multiply each set of dimensions, which in this case is a 1 times the y sections, resulting in a 1, 4, 9, 16. And now you add them together to get the answer 30. So bam, boom, you're now complete. I know I spit out of control, but hope you can see I couldn't help myself, but hope I did with finding down the area under the curve. And that's it. Yeah, now that's it.
Connor, you did it again. You completely forgot to explain left and mid RAM, but I guess I'll pick up the site. You see, when you're using the left RAM, the curve you draw should touch the upper left-hand corner of each of the rectangles, while the mid RAM, the curve should intersect the midpoint of the top segment of the rectangles.